and the Oyster Creek project were all benefits from that early work and focus. And they then, after we executed them and our performance on them, led to the next wave of projects that included projects like 3 Mile Island, Cooper Nuclear Station, the Columbia Generating Station, and several other units. The work we did there actually led to our continuing work in the advanced nuclear area, including projects such as Clinch River Breeder Reactor.
Well, Clinch River is, I like to say, the past is prologue. Burns & Rowe worked on many things which were almost too early for its time, but was so creative and so exciting that you really enjoyed the work. It was really, and you know, Clinch River, the concept was you can actually design a reactor which maybe had 3% of fissionable materials, and while you're burning up the fissionable materials, you're producing more fissionable materials in the form of plutonium, which then can be extracted, recycled, and put back to run the reactor.
In 1984, Keith Rowe was elected president and CEO of Burns & Rowe, carrying on a legacy which began with his grandfather. Under Keith's leadership, Burns & Rowe has continued to increase its overseas expansion, as originally championed by his father Ken.
We have been involved in the overseas markets for a long period of time. We've been involved in Hong Kong. We were one of the first engineers to move into Korea. We did all the early supercritical power plants in Korea. We have been involved in Thailand from the early birth in the power field. We did the first feasibility study for a nuclear power station in Thailand. We have been involved in Australia for many years as a result of a joint venture established some years ago. We have had offices in Singapore for at least the last 5 years, and we're recently opening an office in Bangkok from which we're going to be addressing the Southeast Asia market.
Through the 1990s, markets changed, with the initiatives for deregulation of the power market expanding. Burns & Rowe responded and became one of the largest designers of gas-fired combined cycle plants in the U.S., the favored technology of the independent power producers. With the early legislative moves of the mid-1980s to bring competition to power markets, small cogeneration and other qualifying facilities launched the independent power movement. Burns & Rowe used its power design skills, contracting responsiveness and flexibility to establish a strong base in this new age of engineering, procurement, and construction management projects.
Example of a set of projects that really shows how we work closely with our clients and our ability to bring technology and innovation to them is represented by the Calpine and Siemens projects that we've done over the years, particularly the cogeneration project.
As an example of a really interesting and challenging project has been the 1,000 megawatt combined cycle project called Greenfield in Canada. And this project was owned and is owned by a combination of an independent power producer, Calpine, and a large international trading company from Japan, Mitsui. We had been doing the engineering on the project, and they asked us if we could expand our scope into doing procurement, services, and construction management and startup. What was different about it was this is a project that's being independently financed. This was a more economic way of doing it, cheaper, using local contractors and using our expertise.
Calpine said along the way that they would, for their most complex plans, the ones that were most technically challenging, they would come to Burns & Rowe because of the confidence they had and the very excellent working relationship they had in our ability to design these plants under difficult technical requirements. It's a real mark of the technical innovation and capability as well as the responsiveness that we bring when we get to working closely with the customer.
Burns & Rowe continues the trend of diversifying into new areas. such innovative breakthroughs as engineering, procurement, and construction, and the fast adaptation of new technologies for improved workflows has quickly become the standard in the third generation Keith Rowe era.
We design now in 3D on the computer, whereas when I went to school and when I started, it was all one member at a time on calculation paper. Every beam, every girder, every column was designed individually.
Burns and Rowe's tradition of first-of-a-kind projects, responsiveness, advanced technology, and a commitment to its clients has earned it a reputation of being the best to the best. Burns and Rowe has been and is known for its innovation and developing first-of-a-kind projects from initial design through implementation, delivering outstanding technical plant design and development work. This can be seen through many of their first-of-a-kind projects. The Oyster Creek Nuclear Power Station is the oldest operating nuclear power plant in the United States, and it's the nation's first commercially owned and operated nuclear plant.
We were the first engineers with the first commercial nuclear plant that got the whole nuclear industry going.
We designed a plant called the AP600 in the 90s.
The AP600 utilized modularization techniques for construction, which allows many construction activities to proceed in parallel. This technique reduces the plant construction calendar time, which saves construction costs and reduces the risks associated with plant financing.
Another advanced technology project that again shows the really breadth and depth of Burns and Rowe's skills and capabilities in advanced technology is the accelerated production of tritium. This is a project for the Department of Energy where they were looking for new ways to produce tritium for the defense programs.
In partnership with Los Alamos National Laboratory, this first-of-a-kind project was designed nearly 1 mile long, with the last third of a mile of superconducting magnets. Los Alamos National Laboratory is a multidisciplinary research institution engaged in strategic science on behalf of national security.
It had extreme technical requirements, and while ultimately this project was not fully built, a smaller version of the accelerator was built, and the project was developed substantially through the fundamental design and early detail design.
On the Department of Energy side, we are involved in a lot of things there, mostly relating to environmental issues, where there's a legacy, as the industry refers to it, of materials that are hazardous and need to be managed effectively or converted into less hazardous material.
The Depleted Uranium Hexafluoride Waste Management Project. This facility was designed for the conversion of depleted uranium hexafluoride to disposable and commercial products. Another milestone was the design of a waste management facility for the disposition of uranium-233 into a safer byproduct, with potential reuse as medical isotopes.
U-233 can be a very dangerous material, and we're involved in a process called downblending that material, which in essence this material is what's called highly enriched uranium, and we would blend it into lower enrichment. By doing that, it's easier to handle it, and it's also less dangerous.
The modular high-temperature gas-cooled nuclear reactor. This technology claims a dramatically higher level of safety and has achieved higher thermal efficiencies than traditional nuclear power plants. The first decommissioning of a large-scale nuclear reactor. The Trojan nuclear plant was Oregon's only nuclear power plant. Burns and Rowe's innovative construction techniques resulted in several patents for grouting and structural support of the reactor vessel. The BZ demilitarization at Pine Bluff Arsenal was an early chemical demilitarization program. The Army produced BZ, a type of hallucinogen, at the arsenal and then destroyed it from 1988 to 1990 at the site. The Pine Bluffs Demilitarization Unit was the first to use independent contractors to destroy the chemical agents. In the 21st century, Burns & Rowe continues its mastery of technically complex facilities, engineering, and designing more than 14,000 megawatts of new capacity in advanced gas turbine projects. Keith's corporate strategy to be the best to the best has been incorporated into every Burns & Rowe project.
What comes to mind when I think of Burns & Rowe is a company that has integrity, has a reputation for cutting-edge innovation and technology.
I think that's a very nice, decent American way to make a living.
I'm very grateful for the kind of people they are. The Rowes are a very fine bunch of people.
When companies talk about people being a critical part of their business, that's true of any business, but it's much more so of a business like Burns & Rowe. One of our great legacies is the outstanding people that have helped us achieve what we've achieved over so many years. We truly deliver our product through our people, so the people interface and the creativity and knowledge and outstanding capabilities of our people is critical to really our relationship with our clients and the final form of our product. People are important in every business, but in a business like ours, where our assets are our employees and they go home at night, it's very, very true, and it's one of the things that has distinguished Burns & Rowe is the outstanding employees and their capabilities that we've had over these 75 years.